Hi guys, welcome back to your new lesson. This is Lakshmikant Tiwari. In this lesson, I'm going to teach you data visualization with the Pandas. Pandas is really very beautiful Python package. You can do almost everything, whatever you can do in the MATLAB. The Pandas comes with the data visualization tools inbuilt already. In my previous tutorials in which I had covered matplotlib, NumPy and the Seaborn etc. and as well as the plotly, in that we had seen that how we can visualize the data by using a Seaborn, matplotlib and the plotly. But in this video I'm going to show you how you can control, how you can plot the data by using Pandas, the inbuilt capabilities itself. You do not need to go with the Seaborn, you don't need to go with the plotly, you don't need to go with the matplotlib. You can directly apply a matplotlib on the Pandas data frame. So I'll be teaching you so much in this video, like first I'll go with the line plot and then I'll go with the multiple line plots together. After that I'll go with the bar plot and then I'll go with the histograms and then stacked bar plot, stacked histogram etc. And once it is done, then I'll show you how you can control its layout into multiple and then the box plot and its coloring, area plot, scatter plot, and apart from that the Hex Beam Plot. And then I'll teach you how you can control, how you can plot a pie plot, how you can control its layout, and then finally how you can control its the shape of the pie plot as well as the font size and its styling into a pie plot. And then we will go with the scatter plot, scatter matrix, which is similar kind of the pair plot. And apart from that we will go with the ENROLL curves, and then I'll teach you how you can control the figure aesthetics into Pandas data frame, like controlling the axis, the coloring, all those things, and introducing a secondary axis, converting into a logarithmic scales and subplots, and all of these things you will be learning in this single tutorial. So please do not forget to like this video. Please do not forget to subscribe these channels. I'll be making so many videos on the Pythons, Pandas, matplotlib, Seaborns and the machine learning. And I'm really very grateful to you. You are watching my channels and my videos. Okay, so let's go ahead and start data visualization with the Pandas. Let's get started with the data visualization with the Pandas. We need to first import necessary package into our Jupyter notebook, and those necessary packages are NumPy, Pandas, matplotlib and Seaborn in case if we need in our tutorial. Okay, so let's go ahead and import all those packages. We can do with import NumPy as np, and then import Pandas as pd. And apart from that, let's do import Seaborn as SNS, and then import matplotlib dot pyplot as plt. And then we are going to use matplotlib into a Jupyter notebook. That's why we need inline command as well, matplotlib inline. Okay, so here we have imported our NumPy, Pandas, Seaborn and matplotlib. Let's go ahead and import our random number generator as well. So we can do that with from NumPy dot random import random, and similarly we can import randint and uniform as well as a sample. Okay, so in case if we need a random number generator into our tutorial. Now the Pandas have a two type of the data frame. One is a data frame and another one is a time series. Okay, so let's say if we see here pd dot data frame, we will get something like this, and similarly if we type here pd dot the time series, we will also get not time series but just a series, we will get these. Okay, so the Pandas data frame is the multi-dimensional multi-dimensional data frame, or you can see a series, but the series is just it has just a single column and an index. Let me show you. Let's first create a PD, a data frame with the DF, as well as I'm going to create a time series with the TS. Okay, so in a PD.data frame we need to give some input, some the data as well as the index. Okay, so if you press here shift and the tab, you will see here it needs the data, index, column and the data type. Okay, now let's go ahead and type here random, and I'm going to generate here 100 random numbers, or let's say the 1000 random numbers. And then the index, I'm going to set here a date. For that we need a date range, and Pandas data frame already have a pd.date range, and in this date range I'm going to say here I need from 2019, okay, the June, and it's today's date is 7. Okay, from this day to 1000 dates. So here we need a periods, and the periods I'm going to set here 1000. Okay, so this is going to be 1000 total days. Okay, now let's go ahead and copy this, and similarly we are going to paste it here. Let's run this. Now we have a TS and the DF together. Let's visualize first the DF with the head command. You will see here something like this, and if we visualize TS here, if we visualize TS with the head as well, we will get something like this. Now you can see here there is kind of a little difference between the time series and data frame. In this data frame we have passed a same type of the data, I mean internal parameter, as we passed into a series, but you see here by default this DF is a data frame type and its representation is kind of in tabular format, but here this representation is kind of into a series format. Okay, now let's go ahead and check the type of DF and the TS as well. So here we can check a type of the DF as well as a type of TS. Okay, so here we have a DF type with data frame and the TS type is a series. Okay, so these are the basic differences between the data frame and the series. Now the data frame can hold a multiple index, multiple column as well, but the time series can hold only one column, that is just this one, and here this is just an index. Okay, perfect. Now we have our data. Let's go ahead and create it with the CumSum. Okay, and here we have this 0. What I'm going to do here, I'm going to write it as index, sorry, the columns. Now we have columns, let's say with the column is value. Now let's go ahead, here we have a value, and before we type here value, I'm gonna put here value into cumulative sum. That's gonna be something like this, dot CumSum. Okay, so let's go ahead and run it. Now it will add as a cumulative sum in, and it will place that into a value. Okay, and here we have a TS as well. Let's go ahead and create TS as a CumSum as well. So in this case we can do with TS dot CumSum, that is the cumulative sum, right? Perfect. Now here we have this value and that value. Let's go ahead and plot this data frame and the time series by using Pandas inbuilt visualization capability. Earlier we had seen our Pandas data frame, Pandas crash course, NumPy crash course, matplotlib crash course, as well as a Seaborn crash course along with the Plotly. Okay, but in that I had mostly focused on NumPy data generated, the data visualization based on the NumPy data generation. And now here I'm gonna do a data visualization on a Pandas data frame itself. Okay, so let's go ahead and do data visualization with the Pandas data frame and the series. And I'm going to first work with the time line plot, and I'll apply a line plot on the time series and the data frame. To do that, what we can do, we can just write here the TS and then plot. So what Pandas do, by default Pandas uses matplotlib behind the scene, and it utilizes the matplotlib visualization package, and it operates those matplotlib libraries or the package capabilities directly on the Pandas data frame itself. That's mean we do not need to write something the plt.plot and the ts. Okay, similarly like this. Okay, the plt.plot, and then we need to write something kind of the ts, right? So you see here we can also plot this with the plt.plot, otherwise we can directly plot it on the Pandas data frame or the Pandas series itself. So this tutorial will be basically focused on working with the Pandas series and the Pandas data frame itself directly. We will be not using any the matplotlib plt or Seaborn, SNS, etc. Okay, so this is how we can plot this. And if you see here inside ts.plot, and if you press here shift and the tab, you will see here different kind of full documentation, and these are the arguments which we can pass, like a styling, and if we want y-axis into logarithmic formats or log formats, if you want to put x takes, y takes, if you want to limit x or y limit, etc. So everything you might have seen into our matplotlib tutorial, these arguments we have applied to control aesthetics of the figure. Now let's go ahead and control the figure size. With the fig size we can control the figure size as well. So in this we can put here the fig size, and let's put it 10 cross 5 and just plot it. Now you can see here we have got a figure size with something like this. Okay, so this is how we can visualize the time series or the series into Pandas. Now let's go ahead and see the data frame, which is a df, how we can visualize the df. So similarly we can apply on the df as well, df.plot, and then we can just execute this command, and we will see here we have a similar kind of the plot. Okay, so this is how we can do our the Pandas data frame visualization and the Pandas series visualization directly without using matplotlib plt, although the Pandas is using here matplotlib behind the scene. Okay, now let's go ahead and see the different kind of the lines, how we can plot, I mean the multiple lines. Here there is just a single line, but let's say if you want to plot a multiple values, multiple columns together in a figure, then how you can do that. Okay, since here we are going to include a multiple column, that's mean we cannot use a series into a Pandas, we need to utilize a Pandas data frame. So let's recreate a Pandas data frame df, which is equal to pd, and although what I'm gonna do here, I'm gonna load iris data, then I'll show you. Okay, so let's go ahead and load iris data with iris is equal to sns.load dataset, and then I'm gonna write here iris. This is gonna load iris data set. Let's visualize this. Let's see first the few rows of the iris. Now you can see it has a sepal length, sepal width, petal length, and the petal width. Now let's go ahead and visualize these into a line plot and see what happens. To do this, what we can do here, we can just simply write here iris.plot, and we will see here all these the columns has been plotted here. Now let's go ahead and see the input parameters, the arguments which we can pass here. You need to press here shift and the tab. Once you press here shift and the tab, you will see here it has x-axis, y-axis. Of course the data by default it takes everything there. In y it has taken iris, but in the x by default it starts from the 0 and it goes till the number of points presents into the data. And then if you want to plot on a multiple axis, then you can pass also axis parameter here. It has a subplots false, and here x none, and here y is a false, all those things. So what I am interested to see here, a figure size. So let's go ahead and see the figure size, as well as it can also give a title, and then it can also give you here okay, perfect. Let's go ahead and first give a title and increase the figure size. Here we have a fig size, and here a fig size is equal to 10 by 5, and now you can see here the figure size has been increased. Let's make it a 15, and now this is quite good, and let's make it 8. Perfect. Now you can see here, and apart from that, what we can do here, we can also pass another parameter, that's the title here. Okay, and apart from the title, I don't see the X label and the Y label. There has to be another method to put here X label and the Y label. Okay, and these are the kind of the plot which we can plot. By default it takes the line plot. Otherwise there are other kind of the plot which we can use into a Pandas data frame with inbuilt data visualization techniques. Okay, now let's go ahead and here I'm going to put here a title, and in this title what we can do here, we can just write here iris dataset. Now you can see here we have got a iris dataset. Now let's go ahead and show you how you can set x-axis and the y-axis labels on the plot. To do that, we need to get axis objects, then we can directly get it with ax is equal to the iris dot plot, and then we can set here ax dot set and then x label. Okay, and then we can set here, say here this is the x-axis. Now you can see it here very clearly. And apart from that, now we can say here ax dot set underscore y label, and then here we can set here y axis. Now we have got x axis and the y axis together. Perfect. Now let's go ahead and see how we can visualize other kind of the plots into Pandas data frame, such as bar plot, hist plot, box plot, KDE plot, which is known as a kernel density estimation, area plot, scatter plot, hex beam, and the pie plot. Okay, perfect. So let's go ahead and first work with the bar plot, and to do that, what we can do here, we can just simply type here the ts dot plot, and then we can pass here a kind is equal to bar plot. Now you will see here a bar plot which we plotted here. The time series is quite big, that's why it is taking a little bit time, otherwise it should not have taken this much of the time. Okay, so you see here this is the bar plot. So what happens, there is so much of the data. Okay, that's why this has become something like this. But if we make it a hist, then you will see here very nice plot. Okay, so the bar plot doesn't take this much of the data. So if you want to make it a little the good kind of the bar plot, to do that, what we can do, we can do kind of the df, and let's plot just a single row into a bar format. Then for that, what we can do, ilog, and that's the for the 0th location. Here I'm gonna do it that with the 0th location, that's the 0th row, and then I'm gonna do here plot, and then kind is equal to bar. Okay, so you see here for 0th we have got just a single value in the df. But if we see, if we set here iris, then you see here sorry, in this iris no numeric data to plot, it is saying that. Okay, so what happens actually, if we type it here iris.ilog 0, it gets the 0th row there. Okay, but here it has also the species, that's why this is non-numeric data. To get it into a numeric data format, what we need to do here, we can do something like the df is equal to kind of this, and then we can drop here, and we are talking to drop here species. Sorry. Okay, sorry. We have here species, and then we can get here ilog with 0th location. Perhaps see this one, this says that method object is not let me see, is dot drop. Okay, of course, then it has a Spacy. Did we get it? No. Okay, we need to get give here axis is equal to 1. Okay, and then we are going to get here otherwise, yeah. Okay, let's go ahead and see first df. What is the df? Now we have got df something like this. We don't have here the string, and apart from that, let's go ahead and insert few more rows behind the working cell. And now let's go ahead and paste it here. Now we should see, oh, this should be the df. Now we have got here. Okay, so here we have a sepal length and sepal width, petal length and the petal width. So this is kind of here a bar plot. Okay, and the similar plot can be visualized with the following as well. If we type here the df dot ilog and 0, and apart from that, we can just simply write here a plot, and then we can write here bar. Okay, so this is another way to plot a bar plot in Pandas data frame inbuilt data visualization library. And now let's go ahead and load here a Titanic data set. To do that, we need to write here a Titanic is equal to sns dot load data set, and then here we have a Titanic. And now we have a Titanic data set. Let's go ahead and visualize it with, let's go ahead and see first few rows with the Titanic dot head. And now I'm going to plot here this data frame along with the x-axis and the y-axis. Okay, in the bar plot. For that, I'm going to do here a p class. To do that, what I can do here, Titanic, and then write here, I can write here a p class, and either I can write here directly plot, and then I can pass here kind is equal to bar. Then we will get here kind of a bar plot for the passenger class. There we have a 3 kind of the passenger class, 1, 2 and 3. Let's go ahead and see it. Okay, so here we have a kind of the bar plot. Okay, and apart from that, so this is kind of the bar plot in this, but since the data is too large, that's why it is kind of you know, this bar plot is getting the too wiggly jiggly. So what we can do, we can go ahead and work with the some random numbers which can give you a better visualization. Okay, so let's go ahead and generate a new data frame. The df is equal to pd dot data frame, and then here I'm going to create here integer random number. So that's the randint, and in the randint we need here low, high and size of the random numbers. Otherwise, what I'm going to do here, I'm going to just create a new random numbers with randin, and the size of the randin is 10/4, and the columns of this new data frame I'm going to give here A and B and then C, and after that D. Okay, and apart from that, let's go ahead visualize this data frame df. We can do that with the df dot head. Here we have A, B, C and the D. Now let's go ahead and visualize this new data frame with the plot dot bar. Okay, now you can see here we have got here something like this. Okay, this is definitely looks great here, bar plot. Now this time this doesn't look good because it has just a single column, and there was so much you know, so much the data to visualize. That's why it doesn't look good. Okay, if you have so much the data, then you can visualize this with the histogram. Okay, instead of a bar plot. If we do histogram, we can see here 1, 2 and the 3, and here we get a frequency. It says that the third class passenger has much more frequency, and first and the second class passengers had almost 200 people were there. And if you count all those things together, you will get that around 1000 data is available. 1000 passengers are currently the kind of were available on the Titanic, although the official numbers could be different, but based on this data set, it says that there are around 1000 passengers. Okay, now let's go ahead and see how we can do this plot with the stacked plot. Okay, to do that, what we can do here, we can pass here stacked parameter as a true. If you want to see here what are the parameters which it can take as an input, then you need to press here shift and the tab. You will see here it can take x and the y and then the keywords. Okay, in the keywords we can give here the stacks and the other kind of parameters as an input. Okay, so to do that, we can do here stacked is equal to true. Now let's go ahead and see here. Now this new bar plot is kind of into a stacked format. Okay, and similarly what we can do here, we can plot this plot with the df dot plot, and then we can say here, then we can say here kind is equal to bar plot. Now we have got something like this, and then we can pass here stacked is equal to true. Right, now you see here, so we have got different kind of the plot, I mean the same plot with the different kind of the techniques. Now let's go ahead and see how we can change this vertical bar plot into a horizontal bar plot. To do that, what we need to do here, we need to just write here df and then dot plot dot bar h, and we need to just pass here stacked is equal to true. Now you see here we have changed this vertical bar plot into a horizontal bar plot. Okay, so this is all about the bar plot and a line plot. Let's go ahead and see how we can plot a histogram. To do that, let's go ahead and see a histogram with the iris data plot. Okay, and to plot the histogram, we have the two methods in the Pandas data frame. We can do either with the iris dot plot dot hist, and here we will get a histogram. Okay, so here the four type of the data we have, and for each of the histogram these are the different kind of the plot. And similarly we can say here iris dot plot, and then we can pass here kind is equal to hist. Once again we get a similar kind of the plot, and similarly we can pass here the other arguments as well. Okay, now let's go ahead and you see here these four plots are mixed together. Okay, sepal length, sepal width and the petal length together. Okay, and let's say if you want to stack these the histogram plots one after the another, then how we will do that? To create a stacked histogram, we need to do stacked parameter is equal to the true. Let's go ahead, see with this iris dot plot kind is equal to hist, and then we can say here stacked is equal to true. And you see here now this is kind of a stacked parameter. Okay, stacked plot. Okay, one after the another. And similarly we can increase the bin size as well. So here we can say here bins is equal to the 20. Now the bin size has been increased, and if we pass here a 50, now the bin size is kind of a little more than the 20. Okay, so if you don't pass any the kind of the bin parameter, then this automatically takes bin parameter, I mean matplotlib or Pandas automatically calculate a best bin numbers which suited to your plot. Okay, now let's go ahead and change this vertical plot into a horizontal plot. To do that, what we can do here, we can just write here the orientation. Let's copy this and paste it here and pass orientation. Okay, so here we have orientation, and orientation is horizontal. Okay, and if we put orientation is equal to the horizontal, then we will get our vertical histogram into a horizontal histogram. Okay, perfect. Now this is the kind of the histogram on the same data. Let's say if you want to create a histogram for differentiation of a data set, then how you can do that? Okay, I mean the difference. Okay, to do that, what we can do here, we can just call here the iris dot diff and then dot plot. Then it should get the differentiation. Somehow it's not getting, although if it is not getting, what we can do, we can just pass here. Let's check it if it works. The sepal length. Okay, yes, so you see here the difference between the sepal length and its frequency has been plotted here. Okay, so this is how we can do with you know, the difference plot. Okay, now let's go ahead and see how we can plot our histogram into multiple subplots. Okay, let's say if you want to plot sepal length, width, and petal length and the width into multiple subplots, then how we can do this into Pandas data frame. To do that, what we can do here, we can say here iris dot diff. If you see here, this says that sorry, there is str, that's why it is giving that error. Do we have df? What is the, yeah, no, df is another kind of things. So let's get a df once again with the iris. So here we have a iris, and then we have a drop. Sorry, in the drop we have here is passage, and the axis on which we want to drop, that is one axis, the first axis. Okay, and then here we have a df. Let's go ahead and see a df. That's kind of differentiation. Okay, perfect. So the first number is NaN. Of course that would be the NaN, because if we subtract this 0 from the not a number, that would be always NaN. Okay, now let's go ahead and see this into a multiple column. Then how we can do that? We can just do that with the def dot diff, and then we can just plot here a hist, and during hist you can see here, now we have here are the 4 parameters. Okay, the petal length, petal width, sepal width, and the sepal length, right? And apart from that, let's say if you want to pass here a color, let's say if you want to change a color, you can change the color into the red, and let's change alpha. Alpha is kind of the transparency, and let's make it 50, as well as let's change figure size. We can do that with, let's say, 10 cross 10, and just plot it. Now we will see here. Okay, so this is how we can plot a histogram for each of the column into a different the subplots. Okay, perfect. Now let's go ahead and see how we can plot the box plot. Okay, let's go ahead and see if you want to understand the petal length, petal width, sepal length, and the sepal width, the maximum and the minimum, the values and its median and other the concentration of these values, then how we can do that. Okay, to do that, what we can get here, we can just write here df dot plot, and then we can just pass here a kind parameter, and in the kind parameter we can just pass here box, and as soon as we passes here a box, it can give you a box parameter. And let's go ahead and change the figure size to, sorry, this somewhere 10 cross 10, and see what happens here. So we have a box plot something like this. 10 cross 10 is not visually good. Let's go ahead 10 cross 5. Now you can see here. Okay, so the sepal length is kind of, its median is somewhere around 6, and the sepal width median is around somewhere 3, but the petal length median is somewhere around 1.5, and the petal length maximum, that's this one, that is around somewhere here, and this is upper quartile, that's the 75%. That's when the 75% the petal width is less than around 1.8, and here the 75% the petal length value is around less than 5. Okay, so this is what we can visualize with the box plot. Now let's go ahead and see how we can colorize this box plot. To do that, there are 1, 2, 3 and the 4, and we can pass here a color parameter. So let's go ahead and pass here color parameter, and I'm going to create here a dictionary with the boxes, and in that dictionary I'm going to say here dark green, and then we have, let's say, a red, and then we have here a blue, and then finally here we have a black. This is about the boxes, and let's go ahead and color a median. And to color the median values, we can pass something else, but here I'm not gonna change median. Just make a color here. It says that the invalid syntax. Let me see what it had made here. Sorry, the boxes is dark green, and the whiskers, okay, whiskers which I'm gonna make here, that is gonna be red. And apart from that, I think I'm not gonna change anything there. Now let's see here, we have here a color dictionary. The boxes is gonna be into a dark green, and whiskers is gonna be into a red. And let's just pass it. We can write here color is equal to color. Now you see here, whiskers are into a red color and boxes are into a green color. Okay, so this is how we can change the color. And once again, let's see how we can change this the plot, which is a vertical plot, into a horizontal plot. And to do that, we need to pass here vertical parameter is equal to false. We can do that like this. Now we have here vertical false, it has been converted into a horizontal. Okay, perfect. Now let's go ahead and see how we can do it, how we can work with different kind of the plots, like area plots. Okay, and to do that, I'm gonna just the plot here first, area plot, and then I'll show you how we can do a stacked area plot and other kind of the area plot. So here we have a df, and then df dot plot and dot area, sorry, dot plot dot area. There we have area plot, but this is not a stacked plot. Okay, and similar kind of the plot we can get with the df dot plot, and if we pass here kind is equal to area. Okay, so this is how we can get here area plot as well. Okay, now let's go ahead and okay, sorry, one more thing, this is a kind of the stacked plot. Let's go ahead. By default, what happens into area plot, stacked come by default is equal to the true, and let's say if you don't want a stacked is equal to the true, then what happens? If you set here a stacked is equal to false, then it will not be the stacked there. Okay, now it is working with the stacked is equal to the overlay kind of. Okay, but here you see here stacked is equal to the true, that's why these plots has been stacked, okay, together. Perfect. Now let's go ahead work with the scatter plot. The scatter plot can be drawn by using a dataframe.plot.scatter methods. Scatter plot requires numeric column for the x and y axis, and these can be specified by the x and the y keywords. Let's see how we can do this. To do that, we are going to type here df.plot and then dot scatter. Now once we have, now we need to give x. In the x-axis, I'm going to give here a sepal length. Okay, so here we have a sepal length, and for y we have a sepal, let's say we have a petal length. Let's go ahead and visualize how we can visualize petal length and sepal length together with a scatter matrix. Let's go ahead and plot this. Now with the scatter matrix, we can see here as the sepal length is increasing and similarly the petal length is increasing, okay, in an iris data set. Although if you have a different kind of the data frame, then these relation could be different, okay. Apart from that, it also offers size and color control, as we have seen into a Seaborn and matplotlib based on the third and the fourth parameters, and we can do that as well. So let's go ahead and copy this column and give here C, that is the color, okay. That is the color. C is equal to, if we give here a sepal, let's give a sepal width. With this one, now we can see something like this. According to the sepal length, as sepal length is increasing, accordingly it's the petal length and the sepal length distributions color is being changed. Apart from that, what we can do, we can group the sepal length and the width together, and the sepal length and the petal length together, along with the sepal width and sepal length and the petal width together. That's mean the kind of the grouping into a scatter plot. Let me show you what I'm telling you. Let's create a first axis object for the length of the sepal and the petal. We can do that df dot plot scatter. Now we are going to pass here x is equal to sepal length, and then we are going to pass here y is equal to petal length, and apart from that we are going to give here a label, and this is label is regarding to the length. And now we have here axis object for a sepal length and a petal length. Now let's go ahead and plot for the width. So here we have x is equal to, now we have here plot dot scatter, x is equal to sepal width, and similarly we have for y is equal to petal underscore width, okay. And then we are gonna give here a label, and here this label is gonna be width. Apart from that, we are gonna provide here ax is equal to the ax, that's the axis. Now you can see here we have two different kind of the grouping, but the color is same. So let's change the color and make color into the red. Now you can see here, so this is the grouping for a width, and here this is a grouping for a length, okay. So this is kind of the grouping of a multiple the columns of a data frame together, okay. Now let's go ahead and see this as well as with the color. Let me show you this one. So here we have got sepal length versus petal length, and color is being controlled with the sepal width. Let's control a size with the sepal length with the petal width, okay. That we can do with s is equal to petal underscore width, okay. Now it says that there is just some error. So this says that the type is not correct. What we can do here, I think this should be right. Let me show you. Yes. So the size is being controlled with the petal length. Let's multiply it with 200 and see what happens. Now the color is kind of, the very large here. Sorry, the size is very large. Okay, perfect. Now let's go ahead and see how we can do a hexagonal beam plot. You can create a hexagonal beam plot with the data frame.plot.hexbeam. Hex beam plots can be useful alternative to scatter plots if your data are too dense to plot each points individually. So hex beam plots combines nearby data into hexagonal, and then it changes the colors intensity. Okay, let's go ahead and see how we can do with the sepal length versus petal length. Okay, perfect. So we are going to type here the def dot plot, then dot hex beam, and we are going to pass here x is equal to sepal the length, and we are going to pass here width is equal to petal length. Now here we have x and the y. Let's go ahead and set here a grid size, and here grid size is 25. Okay, perfect. There is some error, perhaps that error is being created by this. So here we have a sepal length and the petal length. Along with that, there is some size, grid size. We can increase the grid size as well, right? That's here the 50, and we can decrease this grid size so that the size will be increased. Okay, so this is how hexagonal beam plot works. Okay, the grid size controls the number of hexagons in the x direction, and default it is 100. If you want a larger grid size, that's mean smaller beams. Okay, and apart from that, the default histogram of the counts around each xy point is computed, and then you can specify alternate aggregations by passing value to the c and the reduce c functions argument. Okay, that means, let's say if we pass here the c is equal to let's pass it with the sepal width. Okay, so it says that there is a sorry, this should be the capital. Okay, so now you can see here it is being controlled by this c. Okay, the sepal width. Now let's go ahead and see how we can work with the pie plot. You can create a pie plot with the data frame.plot.py or series.plot.py. If your data includes any not a number nan or a null value, they will be automatically filled with the 0. A value error will be raised if there are any negative values in your data. Let's go ahead and first create here a random number to see this. Otherwise, what we can do, we can just create here a time series there. I think apart from the time series, we already have a time series, but we need something low data. So we can say here d is equal to the df dot iloc, and the iloc is 0. Okay, so here we have a d, and the d sepal length, sepal width, petal length, and the petal width. These are the value. Now let's go ahead and do a pie plot for this value d. That we can do with the d dot plot and then dot pie. Now you can see here we have a pie plot for this, and apart from that, we can also set here a figure size. So let's go ahead and set a figure size. Here we have a figure size 10 cross 10. Perfect. Now here we have a pie plot. Sepal length, you can see here the sepal length is almost half of other petal width, petal length, and the sepal width. Now you see here the sepal length is 5.1, and if you add these two value, that would be around 5.1. okay, perfect. So this is how it works. Now let's go ahead and you see here how you can add their the legends into a pie plot. To do that, what we can do, we can add the legends, as well as we can work with the subplots as well. Let's suppose that if you have so many columns and the rows, then how you can do that. Let me tell you. Let's suppose that if you create D is equal to df dot head. Now here we have a D, and in the D we have a 5 data set, 5 rows, and to do that we can create here D dot plot dot pie. okay, and apart from that we can just plot it, and once you do that, you will see here this is gonna create an error. So what you need to do here, you need to set subplots is equal to the true. That means it will separate each rows into the different plots. Now let's go ahead and do that. To do that, we can set here the subplots is equal to the true. Now you see here each rows, these has been created into a separate plot, and we can also create here the figure size. We can increase the figure size. Let's increase it to 10 cross 10. Now you see here figure size is increased. Let's increase it a little bit more. We can make it the 20 cross 20. okay, a larger figure size. So this is how we can work with the different the kind of the data frame, the multiple the column and the multiple rows. But you see here it has plotted 0, 1, 2, 3 and 4. And if you want to plot here sepal length, width, petal length and the width together, then what you can do here, we can create here the transpose of this. okay, now you see here it has been changed, and you see here now for each row sepal length, width and petal length and width has been plotted into a pie plot. okay, now let's go ahead and see if you want to put here the percentage inside this one, then how we can do that. And apart from that, let's see if we can do something. You can see here detailed documentation of a pie plot there. It needs x, y value, okay, and then the keywords. There are a lot of the keywords, okay. And apart from that, let's go ahead and show the numbers here inside these plots. okay, to do that, let's copy this and paste it here. And apart from that, let's decrease this figure size to just 3, and we can do that here to pass just 3, and now here we have just 3 pie. okay, the pie plot. Now you can see here the text, the font size is very low. We can also increase the font size, and we can place here number between this. Let's go ahead and do this. To do that, what we can do here, we can say here a font size. okay, so these are the typical matplotlib the arguments. Here I'm going to set here font size is 16. Now you will see here the font size has been increased. And apart from that, now we can see here the number inside the percentage of the number inside the pie plot. We can do that with the auto PCT. okay, auto PCT is equal to, let's pass here the format in which we want to do. That's the floating point. Now you see here, so this is a 50%, and here this is 34%, this is 13.73%, and this is 1.6%. And similarly it works here. So in all these three graphs, if you see there, the sepal length almost includes a 50% of the data in each row. okay, perfect. Now let's go ahead and see how we can do it into a kind of the semicircle, the pie plot. Let's see if you want to cut this pie plot in the half, and then how would you do that. To do that, what we can do here, let's create the time series here. We are going to create a time series with the pd dot series. There, here I have some random numbers with the 0.4, 0.1, that's mean it would be a list for 0.1 0.1. How would you ensure that? You can just write here 0.1 and multiply by 4. You will get a list size of 4, and each number will be filled with 0.1. And apart from that, let's go ahead and create here an index, and for the index for each of these 4 values, we are gonna give index ABCD. So here we have A, and then here we have a B, then we have a C, and then finally D index. Okay, and let's go ahead and give a name, and here a name I'm gonna give here a name is equal to series 2. Okay, sorry, the series 2 is not defined there because we had already defined somewhere. Sorry, here we can work with the TS. Let's see if we can work with the TS. It's not able to work with this TS as well. Okay, this is not gonna work if we cut this one. And sorry, this is the series. Okay, now we need to do the pie plot. How we can do that? We can do that series dot plot.py and just plot it. Now you see here we have got, you know, the kind of the semicircle plots, and you see here this is just 40%, and if we increase it to 50%, what we can do here, we can just make it 0.2. Now you see here, so this is kind of the 80%. Okay, it is 80% filled. Perfect. And here with this we can give here a name. Sorry, this is says that the pie plot. Okay, so here we have a pie plot. So this is how you can work with a pie plot. Let's go ahead and see the scatter plot, how we can plot a scatter plot. To do that, a scatter matrix plot. That's mean it would be kind of the pair plot which we have seen into a matplotlib and the Seaborn. Okay, to do that, what we can do here, we can import that from the pandas. Let's import that from pandas.plotting, import scatter matrix. Okay, so here we have a scatter matrix. It says that scatter matrix cannot be imported. Oh, sorry. Now we have a scatter matrix. Let's go ahead and plot the DF with the scatter matrix. To do that, we need to just pass here a scatter matrix, and if you press here shift and the double tab, you will see here a detailed documentation of a scatter matrix. Okay, so it has a figure size, AX, grid, diagonal elements, markers, density, etc., all those things. So let's go ahead and pass here a data in the form of the DF, and here I'm gonna set here a figure size, and there the figure size is equal to, I'm gonna set here the 12 cross 12. Let's go ahead and see. It says that something wrong there. Now you see here we have got a 12 cross 12 matrix. So let's go ahead and type here plt.show, so that that printed documents will be removed there. And apart from that, let's decrease this size to just 8 cross 8. Then it would be really nice to see here. So here we have a sepal length and the petal length, then we have a sepal length and the petal length. Apart from that, we have a sepal width and other things. Sorry, by default what it do, it plots the diagonal elements into a histogram, and if you want to change the diagonal elements into something else, then you can do just you can just pass here the diagonal elements, kind of this. Let's plot it into a KDE plot, then you will see KDE plot. Okay, so it says that there is some kind of error. Let me see here. Okay, that was a little the mistake into spelling. Now you see here the diagonal elements are now into a the KDE plot. Okay, and apart from that we can also set the color. Let's see if we can set a color here, kind of red. Now you can see here red color. Okay, perfect. Now let's go ahead and see a density plot, how we can do a density plot. To plot a density plot, we will do it into the series, and that is the TS. On the TS we can do just a TS and then KDE, that's the kernel density estimation. And now this is a KDE plot. And apart from that, there are few more the curves which Pandas can be in the Pandas can be utilized, like the ENROLL curves. Okay, ENROLL curves allow one to plot multivariate data as a large number of curves that are created using attributes, okay, of a samples as a coefficients of a Fourier series. So let's go ahead and plot an ENROLL curve. To do that, what we need to do, we need to first import ENROLL curves, then we need to import that from pandas.plotting, import ENROLL curves. Okay, now let's go ahead and write here ENROLL curves, and then we need to pass here our the data, that is df. Okay, perfect. Now let's go ahead and see. It says that the class column is missing, and the class column is, let's say, the pass here a name, sorry, so here we have a sepal width. Okay, so for a sepal width, it has created a Fourier the coefficients for each rows, and then it is plotting in the form of the Fourier coefficients. Okay, perfect. Now let's go ahead and work with the figure aesthetics, how we can control the figure aesthetics. To control the figure aesthetics, like setting the plot styles, controlling the colors, and giving the names, etc., we can do that with the plt.figure, with the passing some arguments into a plot. Let's go ahead and show you. If we do something like this, ts.plot, we get something like this. So let's change the color of this this plot. We can do with the style simultaneously. We can change here a color, and then we can change here a line style. And apart from that, we can also pass here a label. And if we pass here a label, that would be like a series. You will see here a label is series, and if we set a legend is equal to the true, then we definitely get that legends. Okay, and to do that, what we need to do here, we need to do here legend is equal to the true. Okay, now you see here we have got a labeled series there. And apart from that, let's go ahead and plot the iris data set. To do that, what we can do, there the df.plot, and inside that we have here 3 different kind of the plot. And let's go ahead and set off the legends, and we can do that legends is equal to the false. Now the legend will be not shown by default. And apart from that, we can control the figure size with the fig size, and let's make it 10 cross 5. Here we have a figure size. And apart from that, we can also control the scaling. Okay, and let's go ahead, and if we say this is scaling into a logarithmic format, then how we can do that? We can just here set a log y. Okay, log y is equal to the true. Now we will get here this scale will be set into a logarithmic scale. Okay, and apart from that, let's go ahead and plot the sepal width and sepal and the petal width on the secondary y-axis. That's mean what I'm trying to say here. Let's let me show you first df. So here we have a df, sepal length and sepal width. So let's go ahead, show a sepal length and the petal length on a main axis, and let's go ahead and show the sepal width and the petal width on the secondary axis. And if you want to do that, then how you can do that? This is really very simple. To do that, what we can do there, we can create let's say the 2 plot there, let's set to x is equal to the df, then dot drop, and here I'm gonna drop first sepal width, sorry, I'm gonna drop here sepal underscore width, and apart from that we are gonna drop here petal width. Okay, so here we have x-axis, sorry, we need to also define here on which axis we want to drop here. So here we have x into sepal length and petal length, and similarly we can get here the y is equal to the df dot drop, and then we are gonna drop here the sepal length, and that would be on axis is equal to 1. Okay, now let's go ahead and see y with the head. Now here we have a sepal width and the petal width. Okay, so here we have a width and the length together. Now let's go ahead and first plot x on a major axis and then y into secondary y axis. That can be done very easily, and to do that, what I can do there, I can say here x is equal to the plot. There now you can see here I'm gonna set here a figure size is equal to 16 by 5, and apart from that, now I'm gonna also plot here y-axis, y dot plot, and for this I'm gonna also set here figure size is equal to 16 and 5, and then there is a argument which says that the secondary y-axis. Okay, if we set here the secondary y-axis is equal to the true, then the y will be automatically shifted to the secondary axis. Okay, now you go ahead and see, right there the one thing you see here, now it has been shifted to a secondary axis. Okay, and one more thing what we can do there, we can pass here ax is equal to this, and then we can set here ax is equal to the ax, and now we can see that on a single axis itself. Okay, and we can remove this figure size, I think it will not affect, and then we can increase this, let's say the 10. Now you can see here what happens by default, the sepal width and the petal width by default it has written here a right. That's when the axis numbering for a width is by default here a right, and the axis numbering for length by default is a left axis. Okay, perfect. Now let's go ahead and see how we can work with the tick resolution. Okay, to work with the tick resolution, what we need to do here, we need to pass here x compat is equal to the true. Okay, now let's go ahead and just plot a single data there. I'm going to pass here just x. Now here x, and then here we have a figure size is equal to 10 cross 5 there. Okay, and apart from that, I'm going to write here x compat is equal to the true. Okay, now you see here the x would be a little bit more compact, although this is not very much affected, but if you work with the axis which is very wiggly jiggly, then x compat is equal to the true would definitely work. Okay, perfect. Now let's go ahead and see how we can work with the subplots. Okay, let me show you. Earlier we have seen all the plots together. Okay, let's see if you want to plot each of these columns into a separate subplot, then how we can do that. We can just simply type here df.plot, and we can write here subplots is equal to true, and then we can set here some figure size, although I'm not going to set here figure size. Now you can see here it will be a subplots for a different. Okay, by default the share the x is equal to the true, and if we make it a false, then you will see here the x-axis will be for each of these axes would be there. Okay, although let's set okay, what I can do, one more things, I can set here the tight underscore layout. Okay, you see here the axes are being overlapped by the another plot, and if you say here plt.tight layout, then these axes will be separated, okay, very easily. So this is how you can work with the subplots, and you can divide one data set into multiple subplots. Okay, and apart from that, what we can do, that we can also set this layout. By default it has been plotted into 4 different rows, and if you want to control it into a 2 by 2 matrix, then how we can do that? We can pass here another parameters, that is another arguments, that is the layout, and in this layout I can type there layout is equal to 2 cross 2, that is the 2 by 2 matrix. And apart from that, let's set here a figure size, and if I set here a figure size 16 cross 16, you will see here really very big, although I don't want to set it 16 by 16, let's set it 16 by 8. Okay, so this is how we get it. Apart from that, we can also set it the 3 cross 1 as well. We will get something like this. Sorry, I don't think in the 3 cross 1 we should get. Okay, we should get in 4 cross 1, and then we should get 3 cross 2, I think we should get. Okay, so in the 3 cross 2 we will get something like this. Okay, perfect. Now let's go ahead and see into the 2 rows and the 3 columns. Okay, so here we have a 2 rows and the 3 columns. So this is how we can set the layout of the subplots. Okay, perfect. So this is all about the data visualization into the Pandas data frame. We have learned so much in this tutorial, and thank you so much for watching this video. Please do not forget to subscribe this channel, and please do not forget to like this video. Thank you. Bye bye. Have a nice day.